Hello, this session is going on about the absolute value graph. So what is absolute value? It tells us how far away we are from the point 0. Okay, so the value is 0. So 3, we're 3 units away from 0, so that's a 3. Negative 6, we're 6 units away from 0, so it's a 6. Okay, so to show that they're absolute values, we use these double lines. Okay, and remember, it's the absolute value which says how far away it is from 0, or how big something is. We're not caring whether or not it's positive or negative, we're just going to take the value. Now, these graphs do get a little bit tricky, most people do get confused. Now, the positive part's fine, so for example, I'm going to do y equals the absolute of x. The positive part, you just sketch it as usual. That bit's fine, except on the negative, well, any negative we have, it becomes a positive. So, the negative part was originally here, and it's all going to become positive, so we're going to flip it across from the x-axis, so it goes up that way. Okay, so there is our absolute graph. It takes any negative values that we originally had into positive values. So, if we had to say y equals to 3x, then it still does the same thing. However, note that this time we're going to shift it down by 2. Well, we have the original here, which I'm going to use dotted lines to represent. Okay, I won't put the arrows in. And then, we're going to go down by 2 units. So we're going to start from here. So we're going to have one going this way, and one going this way. Note that this time we have 2 x-intercepts, and we need to solve for them. So this one we don't need to do anything. That's a shifted down by 2, so we know it's 0, negative 2. Except for our x-intercepts, we need to put y equals to 0 in. Now, note that there is one for the positive part, and one for the negative part. Because of that, we need to put a plus or minus in front of a 3x when we're solving it. So, you have a plus or minus 3x, minus 3 equals to 0, plus or minus 3x is then equal to 2. So when you solve for it, you then have x equals to 2 over 3 and negative 2 over 3. Okay? Now, you have one on the positive and one on the negative. This only occurs because of our absolute graph. Okay? So it's 2 over 3, 0. And then that's negative 2 over 3, 0. Okay. We can also do it for parabolics. Okay. Except you may see something funny popping up. So just as a word of warning. Now, x squared minus 5, normally, if we sketch it, it's shifted down by 5. So we would have this type of graph. Okay. However, remember that we have any negative values changing into positive. So, these are all positive, that bit's fine, and these are all positive. However, have a look. The bottom bit is negative, so we'll have to flip it over, so we get that. And then we can solve for our x and y-intercepts. Our y-intercept, remember, it's just flipped over on the other side, so we shouldn't need to solve it, because we know that's a 0, 5, instead of negative 5. Okay, and then our other x values would then be, if you solve for it, square root of 5, 0, and negative square root of 5, 0. Now what happens if there's a negative of that? Well, whenever we take a negative of a graph, remember we just flip it along the x-axis. So, we originally already solved for it on the page before, just take the negative of that, and there we have it. I'm going to skip ahead and write out all the points. So, just make sure when you're doing these graphs, you're checking your shifts and checking your negatives, okay? They're not the easiest to start off with, but once you're used to it, it's not that bad. Now, on the CAS, you need to make sure that you are using the right function. You can put these in, but it won't work, so don't use it. You need to put in this symbol, which is absolute function. To get this function out, what you need to do, you'll need to press on the keyboard and then cat, and then obviously absolute.